we need to prove the following. So let's begin from the left hand side. So here on the left hand side, the first term is 1 plus tangent of alpha times tangent of beta whole squared. So we'll expand it using a plus b whole squared. So we have a squared plus 2 times ab. So we have 2 times tangent of alpha times tangent of beta plus b squared. So b is represented by tangent of alpha times tangent of beta, which gives us tangent squared alpha times tangent squared beta. Coming to the second term, we have tangent of alpha minus tangent of beta whole squared. So let's expand it using a minus b whole squared. I'm going to get tangent squared alpha minus 2 times tangent of alpha times tangent of beta plus tangent of beta whole squared, or tangent squared beta. Now 2 times tangent of alpha times tangent of beta and negative 2 times tangent of alpha times tangent of beta cancels out. Now we are left with, we'll combine 1 with tangent squared alpha, and then we're going to combine tangent squared alpha times tangent squared beta with tangent squared beta. But what we'll do, we'll take tangent squared beta as the common factor. So that means we'll be left with 1 plus tangent squared alpha. So this is going to be our first term, 1 plus tangent squared alpha, and the second term is going to be tangent squared beta multiplied to 1 plus tangent squared alpha. Now from the two terms, if we take 1 plus tangent squared alpha as the common factor, so from the first term we've taken 1 plus tangent squared alpha as the common factor, so in its place we'll be left with 1, plus in the second term we have taken 1 plus tangent squared alpha as the common factor, so we'll be left with tangent squared beta in the second term. Now that we have 1 plus tangent squared alpha times 1 plus tangent squared beta, that's equals to secant squared alpha times secant squared beta. The reason behind this is we have a standard identity, 1 plus tangent squared theta equals to secant squared theta. So in the first case we have theta represented by alpha, so we got secant squared alpha, and in the second case we have theta represented by beta, which gave us secant squared beta for 1 plus tangent squared beta. So this is the expression on the right hand side. So hence we have successfully showed that the left hand side is equals to the right hand side, hence